Hello everyone, hopefully you're doing well. In this video, we're going to complete section 2 1.b or 1b, proposition and true values. So if you missed what we already covered, I strongly advise you to watch the previous video on these sections, 1b, proposition and true values, in which we introduce the proposition and true values, truth tables, the negations, the double negations, and also the conjunctions. We introduced the first conjunctions and we went over a few examples because we said that propositions, often join with a connectors like and, or, if, then, if and only if, those are some, propositions that connectors we're gonna see together. We already went over the and, which is the conjunction, the and statements. In this video, we're gonna continue with the logical connectors, and we're gonna see the or. The or is different from and, as you can see. The and, is the, both of them needs to be true in order to consider it's a true statement. However, for or, connectors or can have two different meanings. If it, two different meanings, it can mean, so, the word or can be interpreted in two distinct ways, an inclusive or means either or an exclusive means one or the other, but not both. In everyday life, for example, we determine whether an or statement is inclusive or exclusive by its context. But in logic, we assume that or is inclusive unless they told us otherwise. So inclusive is very important, right? It's very important. You can see a few examples when we talked about the OR connectors. We said for the OR, one of the examples I like to use is, if a health insurance policy says that it covers hospitalization in cases of illness or injury. You see, the health insurance says that they cover hospitalization in cases of illness or injury, illness or injury. So it probably means it covers either illness by itself or injury by itself or both. So this is an example of the inclusive or, that means either or both. In contrast, when a restaurant offers a choice of charter, soup, or a half salad, I don't know, or salad in general, you probably are not supposed to choose both. You either choose the salad or you choose the soup. You cannot choose both, right? Or you cannot have access to both, or you cannot use both. But for the health insurance, you can use either, for it's cover either illness or by itself, or injury by itself, or both. But for the salad and the soup, you can have access to one of them. So for the salad, it's an example of exclusive or, that means one or the other. Right? So the or statement that you see here, it's a compound statement made with or, that we call it disjunctions. Remember, for and statement, we call it conjunction. So we assume that the or is inclusive, so the disjunction P or Q is true if either or both propositions are true, right? So a disjunction P or Q is false only if both propositions are false. So if the first one is true, the second one is true, that means the conjunctions is true, so which is great. If the first one is true and the second one is false, then it is true because you need at least one of them to be true. You see here, if the conjunction, one of your conjunction is true, like Q is true, but P is false, it is true. The only time it is false, it's when you and both of them are false. So for the disjunction, you use or, but you can use also that symbol. So when you see P or Q is the same thing, you write P or Q. It's like PVQ. Remember, P and Q, we can write it as P and Q. As you can see, it's very important to remember and probably make a little cheat sheet, or notes pads, where you can add those symbols and know what's the meanings, right? So we're gonna go with over some examples very quick. In this case, let's see state. What we said here, we're going to state, where the or is used in the inclusive or exclusive sense. So that's what we're gonna do. We're gonna check to see if or is used in the inclusive or exclusive sense in the following proposition. So let's see it. The first one we have, we said that I will either walk or ride a bike to the park. Do you believe we can do both of these? Would that be inclusive or exclusive? I would either walk or ride a bike to the park. So if you go with your bike, you know, then you're gonna go with your bike. If you walk, then you'll leave your bike at home. The exclusive or is used here as it is unlikely that the proposition means you mean both walk and ride the bike to the park. So do you think at some point you can do both at the same time? You can walk and bike at the same time? No, you either walk or bike. So this would be an exclusive or. Before the entree, let's use that one because we're gonna do before the entree, you have a choice of soup or salad. Oh, that's not fair. We just go over this one. What would that be again? Yes, exclusive or is used here because you probably can have both the salad and the soup. That's again an exclusive or for this one. So we're gonna consider this one is an exclusive or. So that's an exclusive or. We said the next book I will read will be the Bible or the Quran. Which one would that be, please? Yes, again here, I don't know why I choose those. The exclusive or is used here in the sense of which book will be read first. Because can you just read one page in this one and you change one page, you want? No, that would be exclusive or anyway. So that means, you know, it's an exclusive or because, uh, you need to decide which one you're gonna read first. So the oil, we're gonna go with the oil, of course. The oil change is good for 5,000 miles or 3 months. That's how they do it. So oil changes are good for either 3 months or 500 miles, whichever comes first. So this is the exclusive or again we use here. So if the 5,000 miles come first, you do the oil change, or if the 3 months come first, you do the oil change. Again, that's an exclusive or. Okay, for some reasons, I think from the book I use all those examples, but I like to scuba dive or surf on my next vacation. So again, here, which one you're gonna see? Uh, you know. I'd like to scuba dive or surf on my next vacations. So the exclusive or is used here because you probably would be thrilled to both scuba dive or surf on your next vacation. You can do both. You may not, but that's inclusive or it would be. You either do scuba dive or you do surf or you do both. That one doesn't stop from doing the other. So those are a few examples, and we can also see here that again with the all statements, remember it's very important to remember the or statement. So if they ask us to do or for the first one, remember for one, we do R, S, and R or S. So if you want to write it that way, that's fine. But the first thing to remember is that is if the first proposition is true and the second is true, you can have both of them true. Or you have the first one true and the second one is false. Or you can have the first one false and the second one is true, or both of them can be false. So those are all the true values you can have in the truth tables when you only have two propositions. Remember, the number of true values you can have is 2 power n. Here you have only two propositions. N is 2, so it's going to be 2 power 2. That's 4. That's why you have 1, 2, 3, and 4. Okay, so we know how many true values we have. And for all, remember you can either write R or S, or you can say R, V, S for all, for disjunctions. And also we said in order for the disjunction to be true, at least one of them must be true. You see here R and S are true, so the disjunction is true. If at least one of them is true, we know they are all true. The only times in the disjunctions or statement, you know, uh, I mean, it's false. It's only both propositions are false. So in this case, the only time it's gonna be false is right there, right? Uh, you know, um, uh, I'll buy you a pizza or a chocolate. If I buy you only pizza, I don't lie because I said pizza or chocolate. If I buy you only pizza, I don't lie. If I buy you only um chocolate, I don't lie because it's still true. If I buy both for you, if both true, I buy you pizza and I buy you chocolate, it's true. But if I promise that I buy you both and I don't, that's when I lie. So that means if both of them false, then it's false, right? So you see for number three, look what happened in number three. Okay, we have, yeah, apologize for my lines. We have P. No, where I put that big P? We have P, but the problem we have not P. Okay, then our answer here is to combine this. So we have P and not P. Remember, we put that symbol for and not P. Okay, this is what happened. First of all, if P is true, what happened? Then not P is false because it's the opposite, it's the negation. If P is false, then not P is true. So what would be the answer for these two? You need to find the answer for these two when you have P. At least when it says and, at least both, I mean, both of, not at least, both of them must be true because none of them, I mean, at least one is false. So we consider the answer would be false for number three. Okay. And you're gonna do the same, uh, or, okay. We said if for number four, okay, we said if you have P and you have sorry, P and Q, only P. If you have Q and we have not Q, and they ask you to find Q or not Q. So what will be the answer? We said if Q is true, then you know that's the opposite, that's the negation, and if it's false, that's the negation. Okay? For all, at least one of them must be true. What would be the disjunction here? Yes. Thank you. Both of them true because at least one is true. But let's see for some of them who have three, like number five. For number five, we have three propositions. So we have P, we have Q, and we have R. So those are our three propositions, and they are the disjunctions. So we have P or Q or R. Okay, that you can also write like P or Q or R. Okay, know that. Now, remember if you have three propositions, remember the number of true values we're gonna have is 2 power n. N is 3, we're gonna have 2 power 3 is 8. So we expect to have 8 true values in this table. So first of all, because we know, all three proposition can be true. Or maybe the first one is true, but the second one is true, but the last one is false. That's possible too. Or the first one is true, the second one is false, and the last one is true. Or maybe only the first one is true, the other two are false. Or you never know. The first one can be false, and the other two are true. Sorry, I can use it that way. True. Or you can say the first one is false, the second one is false, but the last one is true. Or you can say the first one is false, the second one is true, the last one is false. Or all three are false. So with practice, you will remember it, and we know there are in this table 8 true values. So that should be if you count from the second row to the last one, so it gives you 8 in total. Now, we said at least one of them must be true in order for all of them to be true. So what you see then? Yes, thank you. So we know this one would be true, 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 true. The only time it's false is when all three are false. So this one is false. That's how you construct your truth tables. I hope this one help you to do both the and statements and the or statements. Remember, or statement is disjunction and statement is conjunctions. Now, what we're gonna see in the next sections of this, because we do all those logics, we're gonna focus on the logic of if then. That's a conditions, right? If if Patriots wins, those of you, I'm sorry, I'm not gonna use Patriots. Let's go with FC Barcelona for soccer, for football, real football. Okay, so for real football, if I said if Barcelona, FC Barcelona, Barcelona, Barcelona FC or FC Barcelona wins, I will buy you pizza. Let's see this. Okay. Now we have two propositions here. Barcelona wins, that's the first proposition. We can call the first proposition P. Barcelona wins. The second proposition, I can call it Q. I'll buy you pizza. That's a condition here. So the only way I'm gonna buy you pizza if Barcelona win, but not if and only if. It's only if conditions, right? Now look, Barcelona wins, I buy you pizza. So then we can say, oh, you know what? If I say that, then I respect my words. Barcelona wins, I buy you pizza, then I don't lie. So that's a conditions, right? So we have a logic statements, if then. Okay, so that's what we're gonna do. Then we're gonna so that means I don't lie. It's true. Okay, true. Both of them true, then it's true. Barcelona win. I don't buy you pizza. I don't keep my promise. That's false. That I lied to you now. So you see, the only time it's false is when the first proposition is true and the second one is false. Barcelona win. I don't buy you pizza. Then, I don't keep my promise. I lie to you. Now, Barcelona don't win. Barcelona doesn't win, but I still buy you pizza. There is no problem. You're still gonna enjoy the pizza. So I give you pizza even though Barcelona doesn't win. So I don't lie to you then. The only time I would lie to you if Barcelona win and I don't buy you pizza, right? So Barcelona doesn't win, I buy you pizza. It's true. I don't break any promise. Barcelona doesn't win and I don't buy you pizza. That's true also because I don't break any promise. The only time I break promise is number two. Barcelona win. I don't buy you pizza. Then I lie. So that's the only times you have a false statement is when the first one is true and the second one is false. So a statement, as we said, that's a very common way to connect propositions. The if then, that's very important. So we can look and show it having a lot of ways to see it, you know. Then we said a statement of the form if P then Q is called conditional proposition or implications, right? Proposition P, okay, is called the hypothesis, and proposition Q is called the conclusions. So the conditions, if P then Q is true in all cases except the case in which P is true and Q is false. You know, so that's the only one. So P is called hypothesis and Q is called conclusions. Some of the alternative you can always see because it's very important to verify that before we do a few other examples. Alternative phrases of conditional. In ordinary language, conditional statement don't always appear in the standard form if P then Q, right? In such case, it can be used to rephrase the statement in the standard form. For example, you might have the statement as, I'm not coming back. If I leave, you know, uh, you see what I mean? I'm not coming back if I leave. So this one has the same meaning as if I leave, then I'm not coming back. Okay? There are some other statements you can take as an example. More rain would lead to a flood. Okay, we can rephrase that like if there is more rain, then there will be a flood. There are different ways of seeing it that way. So the following are common alternative ways of saying if P then Q. P is sufficient for Q, Q is necessary for P, P will lead to Q, Q if P, P implies Q, or Q whenever Q. So there are many different ways we can say it, for this, If you are leaving, then you are breathing. Well, living, Living. I mean, living. If you exist, if you are living, then you are breathing, right? So that's the necessary and sufficient, right? So that's the necessary and sufficient. We can rephrase that at any time if we want. And breathing is necessary for living. That's an examples you can see if you want to. Like if you are in Denver, then you are in Colorado. Or if you are in Danielson, then you are in Connecticut. If you are in Providence, then you are in Rhode Island. So if we rephrase it, being in being in Providence is sufficient for being in Colorado, right? Being in Providence is sufficient for being in Colorado. Sorry, in Rhode Island. Being in Providence is sufficient for being in Rhode Island. But it's not because you are in Rhode Island, meaning you are in Providence. If you are in Providence, then you are in Rhode Island. You know, point blank, right? If you are in Providence, then you are in Rhode Island. If you are in Boston, then you are in Massachusetts. If you are in Hartford, then you are in Connecticut, right? But if you are in Orlando, then you are in Florida. But it may happen you are in Florida, but you are not in Orlando, right? So that's why you need to be careful when we do those that is sufficient. Okay, so very important this slide that you can save. You know, conditions say it is raining, then I'll bring an umbrella to work. If P, then Q. If it is raining, some of those examples I wanted to share with you. You know, if it is raining, then I'll bring an umbrella with us. You know, and to work. Converse, you know, because as I said, we have so many statements like this that we can use, conditions if P then Q. If you are sleeping, then you are breathing, that I told you. Converse, if P, if Q, then P, you can reverse it. Like if you are breathing, then you are sleeping, you know. So like, the first one I said, if you are sleeping, then you are breathing. Now, if you are sleeping, if you are breathing, then you are sleeping. The same way here, you can shift it. Conditional, if it is raining, then I bring an umbrella to work. Or you can say, if I bring an umbrella to work, then it must be raining. Inverse, converse and inverse are two little different things. So we're gonna see it different ways. You know, if P then Q when it's converse, when in inverse, okay? That's very important. You will see inverse, we're gonna use negative. If not P, then not Q. If it is not raining, then I will not bring an umbrella to work. Converse affirmative and inverse negative. When I say negative, it's mostly you have not in both propositions. Contrapositive, if I do not bring an umbrella to work, then it must not be raining, right? So that's contrapositive. So at some point, we have all of this that we can review and think of conditional, converse, inverse, contrapositive. That I would definitely go over and show you in a table that, at some point I really like you to look at this logical equivalence, because we said, two statements are logical equivalent if they share the same true values. Okay? If one is true, so the other the other, so is the other. And if one is false, so is the other. For example, a conditional proposition is its contrapositive are logical equivalent, right? So converse, we can say that conditional and contrapositive, they are logical equivalents because they have the same. Look, conditionals is the first one here. Contrapositive is right there. These two, they have the same truth table. When this one is true, true. This one is false, false. This one is true, true. This one is true, then true. So we call that a logical equivalence. And the two in the middle are also logical equivalence. So I know we go over a lot of examples, and at that point, it's better we go directly and doing some exercises that we feel like would help us to better understand what we're doing in this section. So the first thing we're gonna do with or, because as I said, we're going to use a lot of or, okay? We said the following statements have the form P or Q. State P and Q and give their true values. Then determine whether the disjunction or statement is true or false. Explain why. That's what we're gonna do, because for these exercises, we know what are they and we can explain at any times. Elephants are animals or elephants are plants. Let's suppose this one is P. We call this one P. and we call this one Q, because we have two statements here, and connect with logical connectors, or it's a or disjunctions. You know, if elephants are, because if I go very small here, P and Q. I mean, elephants. Are elephants animals? Yes, elephants are animals, so we can say this is true. Elephants. Are elephants plants? No, that's false. So you have two statements here. The first one is true. Elephants are really animals, it's true. But elephants are not plants. So elephants are plants, it's false. So what would you say for the disjunction or? So what would you say? Is it true or false if you said or here? What the answer would be? Yes, it should be true because at least one of them true. We call that disjunction is true because a disjunction is true when at least one of its proposition is true. If one of its proposition is true, then it is true. You know, if you go with number two, the the Nile River is in Europe. So let's say if we call the first one right there P, and we call the Ganges River is in Asia. So let's call this one Q. I know at some point you need to know your geography to locate what we're talking about. But suppose, you have only this. That's what you have as information. The Nile River is in Europe. I mean, you need to verify where is the Nile River. Actually, it's not. Okay, so but you need to verify that, like either Googling and or maybe you did some geography. I could ask my son, where is the Nile, where is the Nile River, you know, and it's very important that you connect it. But I think for some reasons, everyone know this is located in the northern hemisphere, northeastern Africa. So it's really not in Europe. So we know the Nile River is not in Europe. So that's totally false. But also, you can check for the second one. Do you feel that the Ganges, Ganges River, where do you think the Ganges River is located? All right. For those of you who do some geography, as I said, I can check with my son who is study geography. I mean, he's only 9, but he's passionate about geography. I can ask him where this Ganges River is. I think before I started this class, I asked him, so he said it was uh, in Asia, somewhere in Asia. So I think it's true. So if this one is true, what is P or Q? Yes, that's true. Thank you. Because we said the disjunction is true because a disjunction is true when at least one of its proposition is true. Here, Q is true then, even though P is false, we're gonna leave it that way. All right. Let's say that I don't know, I can try some other ones. We're gonna do 4. Okay. 2 plus 2 is 5. We're gonna say, let's say is P. 3 plus 3 is false. Is Q. Oh, I give you the answer already. So here, if we have P and Q, let's see. 2 plus 2, is it true or false? 2 plus 2, is it equal to 5? True or false? No, it's false. 3 plus 3, is it equal to 7? False. So what happened when you have two false for disjunctions? Yeah, it's false. Thank you. Because for disjunctions, we said uh, disjunctions is false when all of its propositions are false. And that's what we try to show here. I'm hoping you understand this, even though I'm still planning on doing 1 or 2 or 3 more examples. We have plenty of exercise we can do here. Now, to make a truth table for the given statement, For the first one, remember, if you have only two propositions, you're gonna have 2 power n, that's 2 power 2 is 4. So any times both proposition can be true, or the first one can be true, the second one false, or the first one false, the second one true, or both of them can be false. So we call it truth table. We construct a truth table. But what they ask us to find if the conditional one, okay? So they ask us to do the conditional for this one, right? Conditional means if P then Q. If P then Q. All right, so we write that. The first true, the only times it's false when the first one is true and the other one is false. So remember that, otherwise they are all true. Okay. So either I just do the first one because I know the second one will still be the same. You enjoy the second exercise, but look, because we try to go a little bit faster, I believe you can help to answer those questions. Because at the beginning of this, not at the beginning of this section, but once we're starting to talk about the conditionals, we said that, uh, P, we call it the hypothesis, and Q, we call it the conclusions. And here they said identify the hypothesis and the conclusions in the following, um, you know, conditional proposition and state the truth table. Then determine whether the entire proposition is true or false. So, number one, if trout can swim, then trouts are fish. Okay, what is Q? It's the hypothesis. So if trout can swim, we're gonna call this one P. And that P, remember, we call it is a hypothesis. Then okay, then we can go with this one also. If trout, that we're gonna call this one Q, right? Q is the conclusion because we said conclusions, trouts are fish. Trouts are fish. So this is, this is the conclusions. All right. So we know this is Q and we know this is P, right? I'm gonna just remove it here because I don't wanna get confusions. One is the conclusions, the other one is the hypothesis. So P is the hypothesis, right? Next question, they said, identify the hypothesis. That's P. Identify the conclusions. That's Q. All right. And state their true values. Do you believe? Let's try it. We're gonna try it. Okay. At some point, we're gonna try it. Okay. It's very important that we try it. Okay. To try it, we're going to have P and Q. Okay. Do, okay. What you're gonna do? Trout can swim. Do you feel like trout can swim? So that's the first question you need to. Trout can swim? Yes, trout can swim. You know, if you know trout, you know they can swim. That's true. Okay. And also, do you believe trouts are fish? Yes. Then the conditions, conditional because both of them true. You can conclude that if P, then Q, it's true. Yeah. For number two, look, we know Paris is in France. We're gonna call this one P, or we're gonna call it the hypothesis. And then New York is in America. I mean, are those true or not? Yeah, that's true. New York is in America. That's true. We're gonna call this one Q. or we can call it also the conclusions, right? Paris is in France, that's a hypothesis. New York is in America, that's the conclusion. Is it true? Yes, both of them true. So we can say here P is true, Q is true. So we can say P implies Q. Oh, you can write if, and these symbols right here also means if, then. Okay, to make it shorter. That one is true. Yeah. All right, but look at the third one. New York, Paris is in France. We're gonna call it P, and it is a hypothesis. New York is in China. Do you believe New York is in China? Let's call this one Q conclusions. Okay. Okay, let's go with 3 right there. We're gonna put 3 here. We said P, Q. What happened? Is it Paris in France? Yes. We're gonna say true. New York is in China? False. What would be P? If P then Q then? That would be false. The only time it is false is when the first one is true and the second one is false. So, okay, now you kind of understand how the conditional works. We can go over another examples very quick where we would ask you to express the following statements in the form of P then Q and identify P and Q clearly. So what they ask you to do here, as I said, what is P? When it snows, I get cold. That would be what one? Oh, sorry. This one would be what? Okay, that would be P, and that would be Q. So the propositions, conditional propositions, how will you can write it? If if it snows, then, right? You can say if it snows, then I get cold. Period. That's a sentence. A Bostonian lives in Massachusetts. Yeah. So how would you put this one together? I know, I like this one a lot because it asks you a Bostonian lives in Massachusetts. So what I'm gonna write it down here. All right. Um, I can say a person lives in Massachusetts. I can say P person lives in Massachusetts. I'm gonna say a person. Q, okay. If I said a person lives in Massachusetts, I said that person, okay, okay, that person lives in Massachusetts. So I mean, no, sorry, no, I'm sorry. A person live in Boston. I can say that person. I gave you an example like this before. Lives in Massachusetts. Do you agree with that? Massachusetts is MA for Massachusetts. So I identify P and Q clearly, and they said, express the following statements instead of P and Q and identify them clearly. I can say if a person lives in Boston, then that person lives in Massachusetts. Okay. All right. So I'm hoping you like this one, and usually I do one or two. Maybe you can like the one that says spiders have 8 legs, right? You can do one with spider have 8 legs. If a creature, for number 5, P, a creature, I said a creature. A creature is a spider. Oh, I don't know. An animal is a spider. A creature is a spider. And if you use Q, what would you say for Q? Then, that creator, has 8 legs. That creature has 8 legs. Now, if you want to put it together, if a creature, or we can change it in different ways. If a creature is a spider, then it has 8 legs. See? If then is conditional. Remember, if then we call it conditional uh, statements, right? All right. Last, before we move to our next section, sets of Venn diagrams, we can go with a few examples for converse, inverse, and contrapositive. Write the converse, inverse, and contrapositive of each of the following statements, following conditionals, of the 4 variation set which pairs are logically equivalent. Contrapositive and conditional, they are all like this. I'm gonna just do one of these and probably state what it is, and you would understand. First of all, let me copy and paste. All right, let's go with the first one. I'm gonna do the first example. If Tara's family owns a Cadillac, then they own a car. Is that true? What would be the converse of this? Remember, we said, if you go back for converse means they are positive, right? Conditionals that are all positive. So we call it a converse. Okay? So we said, let's try for converse because it said write the converse. I know that's going to be a lot. That's why I'm going to do one. If, remember we said here, if Tara's family, okay, if Tara's family owns a Cadillac, then they own a vehicle. So that's good, the car, right? If Tara's family owns a car, then they own a Cadillac, right? That would be the converse. Converse means, you just flip P to Q, Q to P, like this one is P to Q. Now the converse would be Q to P, right? If, okay, we're gonna say if Tara's family own, is that own with S, a car, then, okay, they own a Cadillac. Which is maybe true, all right? But not all vehicles are Cadillac, all right? So, but anyway, know that for these examples right here, that's mean we have, oh, I'm gonna put it here. That means we have uh, QP, right? So that's converse. Now they want us to do also the inverse. Inverse, remember, it's all about negations. You need to negate, right? Because if the first one is positive, remember, if Tara's family owns a Cadillac, then they own a car. So for the inverse is if not P, then not Q, right? That's what we said about the inverse. If Tara's family, if Tara family does not own a car, then they do not own a Cadillac, right? So we say it that way because then they do not a Cadillac. If Tara's family does not own a Cadillac, oh, I was supposed to put it different because we said if not P, then not Q. Yeah, we can leave it that way, which is fine. If Tara's family does not own a car, then they do not own a Cadillac. So that's inverse because we said if not P, then not Q, that inverse. And they also ask us to do the contrapositive. Okay. We're gonna say for this one also contrapositive. Remember contrapositive. If not P, if not Q, then not P. Okay. If not Q, then not P. Right? This one here, not P, not P, then not Q. Here would be not Q, then not P. Okay. So let's do it. We said if Tara's family does not own a Cadillac, does not own. Oh, that's what I said. The first one was incorrect. Does not own a Cadillac because there was a Cadillac. Does not own a Cadillac. Then they do not own a car because we cannot switch it on a car. Now, contrapositive, if Tara's family does not own a Cadillac, I mean a car, then they do not own a car, right? So I just do one examples and hope you can use these to do 2 to 6 because we have so many like this. And do not hesitate to look and see if there is any assignments to complete. And I'll definitely see you in the next video to talk about set and Venn diagrams. Hopefully you enjoyed this. I'll see you in the next video. Take care.